Okay. Lesson 3.3.
Hey, we're gonna have a test next week.
Probably.
So we'll have.
Okay. Properties and functions 3.3. We're going to use the same graph that we looked at yesterday. As we were going through some other things and looking at some different properties of graphs and functions. Okay, functions can be split up into intervals of increasing and decreasing intervals. And so on increasing intervals, we'll be going from lower left to upper right. And decreasing will be going from upper left to lower right. And again, when we're talking about intervals, we always start on the left side, least number, and work our way to the right. And so what we do here is we're going to start at -6. Okay. And as we look at this, we're going from a lower left, and we're going up to the right.
Increasing.
And so we're increasing until where?
Two.
Until we get to our x value of 2. So then we say from -6 to 2, we're increasing.
Do we need to draw this graph?
You don't have to.
Then what if we go look at our notes on our sheet?
Say refer to number 9 on page 227. Okay. Then at 2 we start to do what?
Decrease.
Decrease, because we're going from upper left to lower right. And we're decreasing then from 2 until
Hey.
8. And then in 8 we start to
Go back up.
go back up. So we're increasing from 8
To 11.
to 11.
Do we put brackets ever?
Okay, do we put brackets ever? Not on increasing and decreasing intervals.
What if they're going flat?
Okay? If you would have a situation where you have a graph that's maybe doing something like this.
Yep, we had one of those.
Yeah.
Believe it or not.
Which you may,
We did.
okay? How would you say that this graph would be?
Increasing and stagnant.
Okay, increasing from what?
Infinity. Negative.
Negative infinity.
Infinity to 6.
Negative.
No,
4.
not 6.
That's
Negative 4. You're
Oh.
doing your x coordinates here.
My bad.
So we're increasing. Okay, and then we've got this flat line from -4 over to 9.
Stagnant.
And it's called constant,
Constant.
not changing. And then we'd be decreasing from,
We should just call that one inertia. You know? Because it's either constant or just not moving.
so that's how you would do it if it was flat.
Did you know that, Sarah?
No, I learned so much from you, Matt.
It's Newton's first law.
Okay, any questions there on common increasing or decreasing intervals.
No, sir. Now what? When are we gonna do derivatives?
In calculus, do what? If you go from an increasing to a decreasing interval, that point of where it occurs, okay, that means you're going up and then down. That means that you are gonna have a maximum point.
Oh, the min there, I remember doing the max and min.
If you have a situation where you go from a decreasing to increasing interval,
The min.
okay, so we're going from down to up, you then have a minimum.
Are we doing them with our calculators yet?
Nope.
Will we ever?
Yes. So, do I have any maximums on this graph?
2.
Yes.
Okay, this would be a maximum here.
Do we put the coordinate?
What would that coordinate be?
2, 4.
Okay, so we have a maximum at 2, 4.
A minimum at 8.
-2.
8, negative 2.
Okay, maximum at 2, 4. Minimum at 8, negative 2. You would also classify endpoints as maximums or minimums. So over here, this would be a
Min.
minimum as well,
Negative 6, 3.
negative 3. And over here,
11, 1.
minimum or maximum?
Max.
Maximum at 11, 1. Now, if you have a very highest point on a graph, or a very lowest point, those are considered absolute maximums or minimums. Okay, so this 2, 4, that is as high as it gets on any point on that graph. 2, 4 is considered an absolute maximum.
Mr. Hassler, if your line kept going and it went back down, would you have to?
We'll talk about that. We'll talk about that in a second, I think.
Okay.
Okay. Do we have an absolute minimum?
Yes.
No.
Which one?
The beginning
Far
one.
left.
This one.
Yeah.
Because that's as low as it gets.
That's how low can she go?
Okay. Any other maximums or minimums are called relative maximums or minimums. So we've got an absolute minimum, a relative minimum, an absolute maximum, and a relative maximum. Some books will, these relative maximums or minimums will also be called local. But I believe this book does calls them relative. No, it calls them local, so. If I change this graph just a little bit, and I put arrows on the ends,
Your max of infinity.
would I have any maximums or minimums?
Relative.
Only relative maximums or minimums. Okay? We'd have a relative maximum here because this line is continuing to go on forever. It never gets to a highest point. We'd have a relative minimum here because this side goes down forever.
What's the highest you've ever counted to?
Three. No, actually 10. It's my patience with you. Okay, he's in with his stuff. Alright.
What about your sons? What's the highest they can count to right now?
Okay, last thing. And I think we've talked about this before a little bit with symmetry. Even or odd functions. Okay. An even function is one that is symmetric to the
X.
X,
y-axis.
Y,
Odd functions are symmetric to the
X.
origin. Okay, so you will have some questions that want to know, are the functions that they give you even, odd, or neither? If they're not symmetric to either of these,
It's over the X.
well, it doesn't even have to be that. It could be just some graph that's not, doesn't have any symmetry.
What if it's symmetric to all of those?
Then it's not a function.
It's
Oh,
the
yeah.
function.
I was just asking.
If you remember, we talked about how to do these algebraically to determine if it's symmetric to the y-axis. That's where we plug negative x in for x. And does it give us our original? Remember doing that? Did that back in chapter 2.
Yeah.
How did we test for the origin? Both of them. Negative x for x and negative y for y. And see if that gives you your original. Okay, 3-3 for Monday.
Test Friday. Better. That's what's. Why are we skipping 3-6?
What?
This will be his, I think that we need to make sure we count there now.
Yeah, that'll set up perfectly for a test, cause 3-4 Monday, 3-5 Tuesday, Wednesday review,
Probably test on Friday.
go over review Thursday, that's Friday. And then we have no homework for the weekend.
Yeah, then we can get back and we have a pizza party.